In this video, we are going to learn about some basic technology used for the designing of atmosphere distillation column, like flash zone, bottom stream stripping, overflash, and total distillate. So the first thing, that is the flash zone. So let us suppose this is the atmosphere distillation column, and especially this is the bottom section of the atmosphere distillation column. So what is the flash zone? The space, a zone, or the location in the atmosphere distillation unit where the feed is entering is known as a flash zone. So if suppose this is a feed that is entering in this particular zone, so this place is known as a flash zone. Why it is flash zone? Feed entering is flashed in this zone. So that is the reason behind this one. Flashing is there, means the vapor phase of feed goes to upward, whereas the liquid phase of feed goes to downward section of the column. So flashing is there in this zone. The liquid coming towards the lower section of the column, and the vapor goes upper section of the column. And this is happening at a very base or bottom of the atmosphere distillation column. Second term, that is the bottom stream stripping. So what is the meaning of bottom stream stripping? Let us take the same case, bottom section of the column, this one. So this is a feed and this is a flash zone. So steam stripping, the bottom stripping steam is used to recover the light components from the bottom liquids. What happened? There are bottom steam. So that is basically used for the recovery of the basically the lighter fractions from the liquid. So in the flash zone, what happened that in the distillation column, approximately 40 to 50% of the crude is vaporizes. So out of the total feed, only 40 to 50% crude is vaporized, remaining is liquid. So this is the vapor, that is about 40 to 50% of the feed. Still remaining 50% is in the liquid phase. So what happened? This liquid is coming into downward section. So the unvaporized crude travel down the stripping section of the column containing 4 to 6 plate. So this is the bottom section. This is, you can say, the stripping section where there are different type of trays. For example, let us assume there are 4 trays. Normally 4 or 5 trays are there in the stripping section. So this whole section is called as the stripping section, bottom stripping section. So in this stripping section, what happened? This a portion of the liquid is taken out. A portion of this liquid is taken out. So that's why basically, for example, this is a liquid, and with the help of this steam, a portion of this liquid is taken out with the help of this steam, bottom steam, and that is basically the low boiling point distillates. So the portion that is taken out from this heat is the low boiling steam, that is the lighter fractions from the given liquid. And this is basically called the bottom stream stripping. The purpose of bottom stream stripping is clear. It is basically for the stripping of the lighter fractions from this given liquid, and it is useful because only 40 to 50% is vaporized because of the flash zone, and 5 to 10% is about from the stripping. So total near about say 55 to 60% of the total crude is vaporized and taken out in the different fractions and as a different products. So the steam rate is normally used as 5 to 10 pounds of the steam per barrel of the stripped product. Normally in this way we are providing the rate of stripping. 5 to 10 pounds of steam is required for the per barrel of the stripped product. This one is the stripped product. That this is the stripped product. So on the basis of this, we can go for the material balance. Now the third criteria is the overflash. So what is the meaning of overflash? So it is the vaporization of the crude over and above the crude overhead and side stream products, and simply the total distillates. In other words, again I am repeating, it is the vaporization of a crude over and above the total distillate. What it means that, what is the meaning of total distillate? So for example, this is a feed that is entering in the column. The bottom, we can get the bottom section, and then what happened, the things 40%, 50% that is vaporizes, they are taken as different products, D1, D2, D3 and D4. These are the different distillates. This is the top distillate, and these three are the side distillates. And if you add all these three, all these four completely, so this is called as the total distillate. So all these four is known as the total distillate. So total distillate is D1 plus D2 plus D3 plus D4. So that is the complete vapors from flash zone. So all the material that is vaporized in the flash zone is taken out as a D1, D2, D3, D4 and so on. So that is called the total distillate. So you can see here. So overflash is what happened. Overflash is basically the over and above. So total distillate, then again we have to vaporize overflash a small amount extra other than the total distillate. We have to vaporize this amount. So that is called the overflash. Why we need overflash? Overflash is generally kept in the range of 3 to 6 liquid volume percentage or 2 to 3 volume percent of total crude. Normally only 2 to 3% of the total feed is basically taken as the overflash that need to be vaporized over and above the total distillate. So we can say the total vaporization required is total amount of distillate plus overflash. If suppose 50% is total amount of distillate and 3% is overflash, so total vaporization required is 53%. Example, 50 volume percent crude is vaporized, overflash is 3 volume percent, so total is 48 volume percent in this second example. So in this way we can say this is the basic concept of the overflash. So why we need overflash? That is the big question. So what happened? Overflash first prevent the cooking of the wash section plates and carry over of coke to the bottom side stream and ensure a better fractionation between the bottom side stream and the tower bottom. So this word looks like some weird, but I'm explaining it again. By providing the reflux to plate between the lowest side stream and the flash zone. So this is basically the concept of the overflash. I will explain again in just by after 1 second, 2 seconds. Limitations of the overflash. What is the limitation? A larger overflash also consume large utilities. Therefore, overflash is kept to the minimum value consistent with the quality requirement of the bottom side stream. So we cannot go for unlimited value of the overflash. Overflash is desirable. If you increase the value of overflash, obviously the quality of the product will be improved. But if you decrease, you cannot increase much more about the overflash because that basically requires a larger amount of utilities. That's why we can have the optimum value of the overflash number 1. And I'm explaining this concept again. What is happening here because of the overflash? So basically, or what happened? This is column. Say for example, bottom column, and this is section. This is a section, flash zone section. And the vapors will go upward section. So these are the vapors. Vapor are going upward section. So obviously there are different trays. These are the different trays. So these trays are there. So in each tray there should be a vapor liquid interaction. So that is compulsory here. So the question is here, these are the vapors. There are no liquid. That is a big question. No liquid. If there is no liquid, then how can we maintain the vapor and liquid in all these trays? So if there is no maintenance of vapor and liquid in all these trays, means there is no equilibrium and there is no mass transfer. So for that thing, we need an extra amount of liquid vapor that has to be liquefied near about these temperatures. At these temperatures, all these extra amount of vapor will be liquefied, so that amount of liquid will be presented here, and because of this we can maintain the quality of the bottom product also. This bottom product also we can maintain. Basically the coking is avoided because of this reason. So this is all about the concept of the overflash.